Hello class. So today we are working on the 7.2 section review. So we are not learning anything new today, and hopefully all of the things that we talk about sound familiar to you and is good practice for our upcoming Module 7 knowledge check. Okay, so for this lesson, we will be doing just a few of the problems. We'll be doing numbers 2 through 5, 9, and 13. Okay. One of the biggest themes of this entire section was the concept of surface area and volume. Uh, this was something that I wanted to stress a lot of, and I feel like some of us are pretty comfortable with surface area according to our office hours participation. So I'm going to provide as much detail as possible so you know you have a reference again. But if this is easy for you, then that's great, um, and just follow along. And okay, so the way I like to teach it again for a rectangular prism, especially when you're finding the surface area, is I like to label these faces with what I describe them with. So like this right here is called a front face. We know that for surface area, we know that the total surface area is comprised of 6 total faces. So we have the front, which is going to be 4 times 7. We have the right, which is going to be, in this case, 7 times 7. And then we have the top, and as you can see, there is a double use of 7. So we will have a situation where it looks like it's the same exact um, panel. And it looks like the front is actually the same as the top because the top is also a 4x7 rectangle. That's okay. Hopefully that's not too confusing. And let's go ahead and calculate these values. Okay, so 4 times 7 is 28. 7 times 7 is 49. And the top is going to be 4 times 7, which is 28. Okay, remember, we're trying to find the total area it takes to wrap this entire three-dimensional shape. Okay, so now that I have all three of these numbers, I'm going to add these all up. And 28 plus 28 is 56. 56 plus 49. 56 plus 49. It's kind of like doing 56 plus 50 minus 1. So that's going to be 105. Okay, but we remember, class, that this is only 3 of the faces. So in order to calculate all 6 of the faces, 6 faces total, we need to then take this number and multiply it by 2 to get a grand total of 210 meters squared. That's the surface area. Okay. You double it because if there's a front, there's also a back. If there's a right, there's also a left. And if there's a top, there's also an identical bottom. Okay, so that's why you double it. It's really important that you double it. Okay, now volume is just such an easier calculation because you're just technically finding the area of this front face, right? You find the area of this front face, which is, we know, is 4 times 7. And once you find the area, you then have to multiply by the depth of the object. So it's really 4 times 7 times 7. Okay. So we know that 7 times 7, you can always manipulate which numbers you multiply first. We know that this is 4 times 49, and I know that 4 times 49 is like 4 times 50 minus 4. So it's really 196, and it's meters cubed. Okay, so the surface area and the volume of a rectangular prism, to me, is a pretty straightforward concept. You just have to make sure you account for all the faces, and to calculate the volume, you just take this front panel, this front face, and just multiply by the depth of the object. Okay? Hopefully that was good review. Another good review question is number 3, which is a triangular prism. Okay, so the triangular prism is not as easy as a rectangular prism, but you should realize that there are 5 faces total here instead of the 6 that you see in a rectangular prism. And the good news is there is one pair of identical faces, right? Triangle 1 and triangle 2 are identical. So if you just find the area of the first triangle, you can just double it, okay? So let's find the area of the triangle. It's 8 times 6, but we also know that a triangle, you have to divide the entire product by 2. So it's 8 times 6 divided by 2, which gives me 24. And this is feet squared. So then you know the other triangle is also 24 feet squared. Okay, so far so good. Okay, so now we have to calculate the 3 panels. Okay, there are 3 panels that we see. The first panel that I think is the most obvious is this one right here that I bolded. I'm going to call this panel R, which stands for right. There's also a panel to the left. And then there's also going to be, I'm running out of space. I'll put it right here. I know that's a little weird, but I'll put panel and I'll put panel B, which stands for bottom. And maybe I should have done all this calculation over here or on the left. I apologize. Okay. Panel to the right is going to be 10 times 13. Notice how the depth is very important, the 13, because all of the panels have a depth of 13. The panel on the left is going to be 8 times 13. And then the panel on the bottom is going to be 6 times 13. Okay? It is not a coincidence that all 3 of these have a 13 because that's the actual depth of the triangular prism itself. Okay? So then 8 times 13 you get 104. 6 times 13 you get, is that 78? And you then have to add up all of these numbers, 24, 24, 130, 104, and 78. So I'm going to write this on the left. 24 plus 24 plus 130 plus 104 plus 78. Now, obviously, you can use a calculator, but let's challenge ourselves. This is 48. 130 plus 78, I'm going to add them because it's easy. That's going to be 208. And then I'm going to add a 104 at the very end, which is the middle number. Okay. 48 plus 208 is 256. And 256 plus 104 is exactly 360. Wow, that's such a clean number. It's nice. 360 feet squared is the final surface area. Okay. So a triangular prism is a little bit harder because there's no shortcut really, other than the fact that the triangles are identical. And so you kind of have to calculate each face individually. Okay, so for volume, all you have to do is calculate the area of the base. And in this case, since it's a triangle, right, this triangle is considered the base, and this triangle is considered the base as well. Okay, so remember, prisms must have parallel bases. Okay, and in this case, the triangles are the bases. So if you find the area of the base, all you have to do after that is multiply by the depth of the object, and you will find the volume. Okay. The good news is we already know the triangle. The area of the triangle, which is the base, is 24. and then all we have to do is multiply it by the depth of the object, which in this case is 13. Okay, so 24 times 13 is going to give me a grand total of, isn't that 240 plus 72, which I believe is 312 feet cubed. It is cubed because there are 3 dimensions for volume. Okay. So triangular prisms and rectangular prisms, you want to be very, very comfortable calculating both the surface area and volume. I don't think it's too hard if you practice it enough. And let's see if we can squeeze in one more question into this. Let's see. So, okay. So there is kind of a shortcut if you are very, very comfortable with finding the surface area of a rectangular prism. You just know that there has to be 3 different combinations for the 3 dimensions given. Okay, so I'm gonna shorten this by saying surface area, and you'll see that I can do this very, very quickly just because I already know what the 3 different combinations are, right? So the first combination is going to be 8 times 15. These are the 2 first numbers that are given. I then am going to do 8 times 2. That's another different panel. So you see 8 times 15, 8 times 2, and then the third pair left inevitably has to be 15 times 2. Notice that all 3 of these pairs are different in their, in the way that they are multiplying numbers, right? These are 3 different combinations. So 8 times 15 is 120, 8 times 2 is 16, and 15 times 2 is 30. Okay, now remember class, these are only 3 of the 6. So really, essentially, I'm going to add this all up, and then I'm going to have to double it after that. So 120 plus 46 is going to equal, is that 166, right? 166 times 2 to double it is going to give me, is that 16, and that's 32, so it's 332, okay? And then you want to write centimeters squared. Now again, I'm using a lot of mental math. You should definitely use a calculator if you're not comfortable with 166 times 2. And that's the surface area. It's really, really that simple, okay? The volume is even easier. Remember, the volume is literally just length times width times height. Sometimes we'll call it depth. This is the third dimension. And in this case, you just do 8 times 15 times 2. That's going to give me 240 centimeters cubed. Okay, 15 times 2 is 30, and 8 times 30 is 240. Okay, so if the prism is scaled by a factor of 3, what is the new surface area? Well, this is a concept that we talked about in the last lesson, right, class? The scale factor is 3. So that actually will affect the area by not just 3. It will make the total area 9 times larger. So the surface area of the new image should be 9 times larger, right? Because surface area is 2-dimensional. So if it should be 9 times larger, 332 times 9 is going to be 2988. Okay, it has to be 9 times larger because the scale factor was 3. If the prism is scaled by a factor of 4, what is the new volume? Well, this is an interesting question because we know that volume is 3-dimensional, and it is not just 4 times bigger for volume. The new volume should be not only 16 times bigger, the new volume must be 64 times bigger.
Right.